would like to express my sincere thanks to Dr. Paddy for inviting me to deliver lectures on T-test. I will discuss in detail without wasting time. I am going to share my slide. Paddy sir, is it visible?
Not yet, sir. Yes, now it's visible.
Yes, sir. Let's start today's presentation. Dr. Paddy directed me to speak on the title Application of T-test in Medicine and Public Health Data Analysis. Today we will discuss about only one technique that comes under the category of parametric statistics. I divided this presentation into 5 different parts. First, we will discuss about the basic concept of statistical tools for 2-3 minutes. After that, we will discuss about the t-test and its types, since there are 3 different types of t-tests which are used to analyze data in the field of biomedical researches. In the third part, we will discuss about the first type of t-test, independent t-test. I will demonstrate this by the help of a hypothetical example. In the fourth part of my presentation, I will discuss about the dependent t-test, application of the second type of t-test that is known as dependent t-test. And in the last part of presentation, we will discuss about one sample t-test. Let's start with the first part, that is basic concept of statistical techniques. Ladies and gentlemen, for analysis of data, we require statistical techniques, and we know that these statistical techniques are known as inferential statistics, since these techniques are used to draw inferences after analysis. And we have discussed in the last part also, last session also, these inferential statistics, or we can say that these statistical techniques are classified into 2 subcategories, parametric and non-parametric. And there are some assumptions, and these assumptions should be fulfilled to apply parametric statistics. And one main assumption is the data should be normally distributed. If the data is normally distributed, in that case we can apply parametric. Otherwise we have to apply parallel non-parametric technique. Second one is at least interval or ratio scale is required, and we have discussed in the last session there are 4 scales of measurements. But on the other hand, the non-parametric statistics can be applied in any distribution, maybe normal, maybe non-normal, and in any scale of measurement. And we know that there are 4 scales of measurements. First one is a nominal scale. When we collect data in the form of a frequency or counts in a discrete series, number of patients, smokers or non-smokers, maybe smoking, and second category, second type of scale is known as ordinal scale. When it is not possible to measure in a numeric way, in that case we measure in order, maybe ascending order, maybe descending order. And the third type is interval scale, means having same intervals in between but has no fixed zero. And the last one is ratio scale, means having same intervals in between but has a fixed zero. Out of these 4 scales, that is nominal, ordinal, interval, ratio, we can apply parametric statistics in case of only interval and ratio scale, that is third and fourth. And we are going to discuss about the application of t-test, and this t-test comes under the category of parametric statistics. It means there are 2 assumptions, and these assumptions should be fulfilled. First one is the data should be normally distributed, and second assumption is that we require at least interval or ratio scales. Ladies and gentlemen, we are discussing about different statistical tools. Out of all statistical tools, today we will discuss about the one test, that is t-test. And we divide, already we have discussed, we divide all statistical techniques into 2 parts, parametric, non-parametric. We will not discuss about non-parametric. To understand in a better way, we divide parametric statistics into 2 subclasses, into 2 subparts, that is comparative and relationship. Comparative statistics, these statistical techniques that comes under the category of comparative, It's clear these are used to compare different groups. On the other hand, the technique comes under the category of relationship statistics. These are used to mm, establish the relationship between variables. So, from the category of comparative, different types of comparisons are possible. The smallest comparison can be in between two groups, and we can compare more than two groups also, and we can compare different groups by taking covariate also. So today we will not discuss about the comparison among more than two groups as well as with covariate, but we will discuss about the first category comparison between two groups. Now my story starts. The technique which is used to find out the significant difference between the two groups. The technique which is used to compare two groups is known as T-test. But there are three different types of T-test. First one is independent T-test. Second one is dependent T-test. And third one is one sample T-test. Again, I repeat, independent T-test, dependent T-test, and one sample T-test. We will discuss one by one. Let's start with the first application of independent T-test. Before that, we will discuss about T-test and their types. Already we have discussed about the definition of T-test. T-test is a statistical technique which is used to find out the significant difference between the means of two samples. It is used to compare two groups. And we have discussed that there are three different types of T-test: independent T-test, dependent T-test, and one sample T-test. In case of independent T-test is a statistical technique used to find out the significant difference between the means of two independent samples. The condition applies. We require two groups, but there should be independence among the groups. I will discuss with hypothetical example, but this independent T-test is known by different names. If we study different literature, different books, it's given by different names by the different authors. This independent T-test is also known as student's T-test. The third name of this test is known as the simple T-test, and this independent T-test is also known as unpaired T-test. This independent T-test is known by three different names: students, simple, and unpaired. Again, I repeat, independent T-test is a statistical technique used to find out the significant difference between the means of two independent samples. And the formula is in front of you. Formula for independent T-test is the final output of independent T-test is known as T ratio. On the basis of that, we draw conclusions. The T ratio is equal to DM. DM means difference between means. We have two groups and we have two independent groups. We have to compare two groups by applying independent T-test. The difference between means mean of one group minus mean of second group upon, that is divided by under root SD1 square, standard deviation 1 square. Standard deviation 1 means standard deviation of the first group square upon N1. N means the number of subjects in first group, plus standard deviation 2 square. It means standard deviation of the second group square upon N2 means the number of subjects in the second group.
Sanggu,
Let's discuss with example. An investigator wants to conduct a study on the title comparison of myoglobin between males and females. We know that myoglobin is an oxygen binding pigment present in the muscles, and the investigator want to compare myoglobin between males and females, and the title of the study is comparison of myoglobin between males and females. Subjects, regarding the subjects, the investigator, the researcher decided to conduct the study by taking total 60 subjects. 60 subjects were selected, 30 males and 30 females, and myoglobin was measured for all. If we talk about objective, the researcher framed objective. That is, the objective is to find out the significant difference between the myoglobin of males and females, whether males and females possesses the same level of myoglobin, or is there any significant difference among the myoglobin contents? Hypothesis, the researcher also formulated the hypothesis. It is hypothesized that there shall not be any significant difference between the myoglobin of males and females. Researcher formulated null hypothesis, and the statistical technique used, or the statistical technique applied. Since we are discussing about the application of independent t-test, so to find out significant difference between the myoglobin of males and females, independent t-test is used. These are the row scores. See the row scores. There are two groups, males and females, and the 15. There are 30 subjects in first group and 30 subjects in second group, that is females. Here we have to compare both the groups, and these are the scores of myoglobin contents. And we require three values, that is mean of both the groups, standard deviation of both the groups, and number of subjects in both the groups. Since the investigator conducted the study by taking 60 subjects, 30 in each group, 30 in male, 30 in females, the mean value for male is 10.53, for female 10.46, standard deviation value is 1.65 for both, that is males and females. And number of subjects, since the investigator conducted the study by taking equal sample size, that is 30 for males and 30 for females. If we put all the values of mean, values of standard deviation, values of the number of subjects in the formula, that is DM, difference between means divided by the under root standard deviation 1 square upon n1 plus standard deviation 2 square upon n2, and we get the value of 0.156. So if we want to calculate manually, I will demonstrate by the help of softwares also. So we can calculate this T ratio, and this calculated in this hypothetical example, the calculated T ratio is 0.156. Then the question arises, how to draw conclusions? So how to see we have to compare this calculated value with the tabulated value. So how to see this calculated tabulated T value at 55 degree of freedom? Since total number of subjects are 60, and we have to see at 58 degree of freedom, since the formula to calculate, the way to calculate the degree of freedom in independent t-test is n minus 2. N is 60 minus 2 is 58. See how to calculate. Investigator conducted the study at 0.05 level of significance. See this. See my cursor. The value at near to 60, that is 2. This is the tabulated T value. So how to draw conclusions? In this hypothetical example, the calculated value is 0.156 and the tabulated value is 2 at 58 degree of freedom. If the calculated value is greater than the tabulated value, the significant difference is there. On the other hand, if the calculated T value is lower than the tabulated T value, no significant difference is there. So on the basis of the results, we can conclude that since the calculated T value is lower than the tabulated T value, no significant difference is found between the myoglobin of males and females. Since in this hypothetical example, our calculated T value is 0.156 and the tabulated T value is 2. Since 0.156 is less than 2, it is concluded that there is no significant difference between the myoglobin contents of males and females. Both possesses the same level of myoglobin contents. There is no impact, or we can say that there is no impact of gender on myoglobin. Myoglobin is not affected by gender. So we have discussed about the application of this independent t-test. I will show this by the help of both the softwares. There is a facility in Excel also. We can calculate this by using Microsoft Excel also. Now I am going to show how to calculate the steps to find out the T ratio by using my, in this example, we have, I will copy the same data. On the basis of that we have discussed, I will discuss. We have two groups. See, Paddy sir, is it visible?
Yes, sir, it's visible.
Yes. We have to enter the scores in the Excel in two different columns. That is, in the first column, males, and in the second column, females. I am entering the scores. Suppose the myoglobin contents are 13, 14, 15, 12, 13, 14, again 16, 17, and I am taking only 10 males and 10 females. Now, how to calculate? After entering all the scores, we have to click on data. After clicking on the data, there is an icon. See my cursor, data analysis. Click on data analysis. Then go to Ttest two samples assuming equal variances. Select this, click on OK. We have two groups in this hypothetical example, that is males and females. And go to variable one range. In front of the variable one range, click on this arrow. Select all scores including heading. Again, click on the arrow. Go to variable two range in front of, and click on arrow, select all the scores. Again, click on the same arrow, opt for labels, and click on OK. The results will be in front of you. See how to interpret the results. Manually, we have discussed by taking a hypothetical example. See my cursor. This is the mean score of males, 14.8, mean scores of females, 16.1. And the scholar conducted the study by taking only 20 subjects in this hypothetical example, 10 in this, the category of males, and 10 females. The calculated T value is 1.58, and the critical value is that the critical at two tail is 2 point something. Since this value is calculated value is less than this tabulated value, no significant difference is found. So the facility of this test is available in Excel as well as in SPSS. Now I will discuss about how to calculate this, how to perform this independent t-test on SPSS. This is also available on SPSS. See how to calculate. I am copying all the scores, 20 scores, and I am going to paste in this data view of SPSS. In Excel, we entered all the scores of males and females in the separate column. In one column for males, in second column for females. But in SPSS, we have to enter all the scores in the single column. And in the next column, we have to give the label. For example, One stands for male and 2 stands for female. Now go to the variable view, and in the first column, these are the scores of myoglobin. And in the second column, we can give the name gender or groups. Since there are 2 groups, males and females, and the gender. And in front of the gender, since we have 2 genders, males and females, in front of the gender, go to values and define value the labels. Value 1 stands for males, give the label and add, and 2 stands for females and add. Click on OK. The data entry is complete. Data entry is complete. Now, how to analyze? You may write down the commands also. Go to analyze, go to compare means, go to independent sample t-test, and bring this myoglobin in the test value and this gender in the grouping value. Define the groups. We have only 2 groups, that is 1 and 2, means males and females. Then continue, click on OK. The output will be in front of you. See the output. We are comparing myoglobin among gender, means 2 groups, males and females. And we conducted the study by taking 10 males, 10 females. Mean value for men is 14.80, for female is 16.10. This is the standard deviation value, and the t value is 1.58, and it's not significant. The study shows there is no impact of gender on myoglobin contents. So we have discussed about the application of this independent t-test, and we can calculate this independent t-test by using both the softwares. The facilities available in Microsoft Excel as well as in in SPSS, Statistical Package for Social Science. After discussing about the independent t-test, ladies and gentlemen, please note, the independent t-test is used to conduct survey studies. It's not used, it's not applied to conduct experimental studies, but on the other hand, this dependent t-test is used to conduct experimental studies. How? We will discuss in detail. Let's start with the meaning and definition of dependent t-test.
Sir, can you take 1 or 2 questions for the independent test if some?
Sure, sir. Sure.
Because some people are chatting in the chat. So if you have any quick question or doubt, you may please ask, unmute yourself, introduce and ask question on the independent test.
Yeah, sure. Please ask.
Friends, do not chat because I may not be able to read your chat. Please introduce yourself and ask the question.
Good evening, everyone. Am I audible?
Yes. Good evening.
Yeah, good evening. I'm Dr. Rupesh Sahu. My question regarding this t-test is that, can we use these t-tests and other types of tests if the sampling method is non-random? Because I have read in some text that it has to be random sampling if these kind of tests have to be applied.
Yes, no, you can apply in case of non-probability sampling technique also. For example, in ice ball sampling, in convenient sampling, in judgment sampling. Yes, this can be applied in both the. But in relation to your question, one more assumption should be fulfilled. That is homogeneity of variance. If the assumption of homogeneity of variance is fulfilled, in that case, you can apply in both the types.
Okay.
And I will show you how to calculate this homogeneity of variance. Please see. In case of parametric statistics, we have discussed that data normality is required, but with the data normality, Second assumption should also be fulfilled, and this assumption is homogeneity of variance. How to calculate this? See. But sir, how to manage? Yes. See, go to, this is Excel, but we are discussing in SPSS. Oh, I deleted the scores. No problem. Suppose I am taking a single digit scores, and in the previous example, we entered 20 scores, and we have given the label 1 for male, 2 for, sorry, 2 for female. In the first group, this is myoglobin content. I am writing the abbreviation in this gender, and we divided this in the two. That is 1 for males at and 2 for females at. Okay. Now go to analyze, go to compare means, go to independent sample, and go to options. Bring this and this and this. Define the groups 1 and 2. Continue. Click on OK. See, this is calculated by the Leavenworth test. Is there any? Yes, already it's there. Leavenworth test for equality of variances. If we fulfill this assumption, in that case, this can be applied. But this is an additional assumption for independent t-test. And the homogeneity of variance is calculated by Leavenworth test. Sir, is it clear?
Sir, the interpretation is a bit hazy. The output is given as Levin's test. The both outputs are given. If if you see the SPSS output.
See, sir, first we have to see whether the assumption is fulfilled or not. We didn't today in this hypothetical example. We have not tested the assumption of normality of data. First, we have to test that. If the assumption of normality of data is fulfilled, in that case, we can go further. Then we have to test another assumption, that is homogeneity of variance, and this homogeneity of variance assumption is measured by this Leavenworth test. It should not be significant. If it's significant, if this significance value is less than 0.05, in that case, both the groups are not homogeneous in nature, then we cannot apply this.
Okay.
Sir, is it okay?
Yes, sir. Got it. Sir, if you allow another question.
Sure, sir, sure.
Sir, is there a difference between the T ratios and other kind of significance statistics? If we calculate the outputs from raw data, or versus if we calculate it from directly the means, the standard deviations, and the sample size? Because in some softwares like SPSS, we need raw data.
Sir, in a layman's language, we always say that t-test is used to compare two groups in layman's language. But sir, actually, t-test is used to find out the significant difference between the means of two samples. Actually, we compare means. But in layman's language, we say it's the technique is used to compare two groups.
That means there is no difference if we calculate it from GraphPad, Prism, and SPSS, which utilizes both different approaches.
Sir, that will be a visual difference. There is a difference between the visual difference and actual. Actual means significant difference. Our purpose is to find out the significant difference between the means, significant difference between the groups.
Okay.
Is it clear, sir?
Thank you, sir.
Sir, Uh, the first basic, as you told the criteria before you go for any this t-test and all parametric test, the data should be normally
Please introduce
distributed.
so that
Sir, myself,
Sudarshan can,
Dr. Surya, sir.
Dr. Rajiv can know.
Dr. Surya, sir, from Bangalore. Sir, just how to check for the normality of the data before we proceed with all these statistical tests?
Sir, there are different ways. By using that, we can test the, we can calculate the, we can test the normality. There are three different ways. By applying that, we can find out the normality of data. First method is by the help of descriptive statistics. In descriptive statistics, we require skewness and kurtosis. Skewness measures the symmetricity of the curve, that is normal curve or normal distribution, and this skewness, kurtosis measures the flatness of the curve. So we can apply thumb rule. If the value of skewness or the value of kurtosis, if this value is in between -1 and 1, that means the data is normal. Otherwise, we have to apply parallel non-parametric technique of independent t-test, and parallel non-parametric technique of independent t-test is man-written u-test.
Yes, sir. I just wanted to whether in this Excel and SPSS, can you
Yes.
check for the normality, sir? That's what I'm asking, sir. Just can you
Yes,
demonstrate us?
you can test in SPSS. There is a facility.
Just
I will show you.
show it to
I
us,
am going to
yes.
show you. I am going to
Yes.
show you. See,
Thank you, sir.
we are going to test the normality. In that case, I am removing these scores. See, suppose these are the 20 scores of the myoglobin content of one group. Suppose separately we have to calculate. Is it okay, sir?
Yes, sir.
I have taken this. That is, and these are the scores of. Is it visible, sir? Is it visible? My screen is visible.
Yes, sir. Vijay, sir.
These are the myoglobin scores of how many subjects are there, sir?
30, sir.
30. We are going to test the normality by using SPSS. Go to analyze, go to descriptive measures, and go to explore, and bring this variable. In our hypothetical example, variable is myoglobin content. Bring in the dependent list, go to plots, and see my cursor. Opt for, tick for normality plot with the test. Continue, click on OK, results will be in front of you. In this example, sir, see, the value of skewness is 0.10. Is it okay, sir? See.
Yes, sir. Yes, sir.
And the value of kurtosis is 0.74. It means data is normally distributed. Or another way is you can test the normality by using this QQ plot also. In QQ plot, how to interpret? In QQ plot, a standard line is generated.
Yes, sir. It is a straight line,
and
then
all the
it's normally
scores should
distributed.
be scattered near to this line. If all
Yes,
the
sir.
scores are scattered near to this line, it means data is normally distributed.
Yes, sir.
And there are formal tests also. See these formal tests. Kolmogorov, Smirnov test, and Shapovalov test. There are various ways. By using that, we can test the normality.
Yes, sir. Thank you so much, sir.
Okay, friends. Professor Chaudhary, you may continue the dependent t-test.
Sir, I have one question.
Yes,
Sir,
please.
I have one question. I am Dr. Ankit from AIIMS Raebareli. So I have one question, sir. You said that there should be homogeneity of variance, and the another thing is the normal data. So what I understood that the data should be normal, and if normality is not being checked, then the homogeneity of variance should be there between two independent samples prior to applying the independent t-test. Is it true, sir?
Yes, it's true, sir. It's.
Thank you, sir.
Now we will discuss about the application of dependent t-test. See, let's start with the definition and meaning of dependent t-test. Dependent t-test is a statistical technique used to find out the significant difference between the two different means of same sample in the form of a pre and post. And this dependent t-test is also known by 4 different names. It's also known by dependent t-test, paired t-test, one sample t-test. Sorry, these are by mistake I have written this. This dependent t-test is known by repeated measure t-test, paired t-test, and correlated t-test. Formula for this is dm, difference between means, divided by under root standard deviation 1 square upon 1 n1 plus standard deviation 2 square upon n2 minus 2r. R is the coefficient of correlation into standard deviation 1 upon under root n1 into standard deviation 2 upon under root n2 means number of subjects in the second group. If it will be clear by the hypothetical example, investigator want to conduct a study on the title that is the that belongs to an experimental study. Investigator want to conduct an experiment on the title effect of drug X on lymphocytes of PGIMER students. There is a drug named X and investigator want to find out its effect on the lymphocyte counts. Subjects that scholar or researcher selected 45 male subjects and from and the measured lymphocytes were measured twice. Objective of the study is to find out the effect of X on lymphocytes of PGMR students. Hypothesis is, it is hypothesized that there shall not be any significance of drug X on the lymphocytes, and the statistical technique used is there to find out the effect of drug X on lymphocytes. Since we are discussing about the application of dependent t-test, the dependent t-test is used. See the calculation manually. See this, we require mean of both the columns, that is pre-test and post-test. Here in layman's language we can say that the dependent t-test is used to find out the significant difference between the two observations of the same group in the form of a pre and post. And independent t-test is used to conduct survey studies. On the other hand, this dependent t-test is used to conduct experimental studies by taking a single group design. We have two observations. Observation 1 means pre-test, observation 2 post-test, and in between we have to give the treatment. And in this hypothetical example, treatment is drug X. If we all the values, and in this with the mean, standard deviation, and number of subjects, we require one more value that is known as R. R means coefficient of correlation, that is 0.92 in this example. If we put all the values in this, in that case, the T ratio is the calculated T value is, we can say T value, we can also say T ratio is 6.35. We have to ignore the sign, minus sign. The T ratio cannot be in minus, since we have to calculate difference between means. Difference between means means we have to subtract lower value from the higher. That will always be in positive value. We have to ignore this sign. See how to see this tabulated value at 44 degree of freedom. Since this, in this hypothetical example, investigator conducted this study by taking 45 subjects. In this, the formula for calculating DF is n-1. Since there is one group, in that independent t-test we were having two groups, so the formula was n-2. In this n-1, 45 minus 1 is 44. So we have to see at 0.05 level of significance, or we can see at 0.01 significance level also, and the value is 2.012. How to draw conclusions? The methodology will be same as independent t-test. In this hypothetical example, the calculated value is 6.35 and the tabulated value is 2.02 at 44 degree of freedom. If the value, this calculated value is less than tabulated value, significant difference is there. If this calculated value is lower than the tabulated value, no significant difference is there. And but in this hypothetical example, the calculated t value is higher than the tabulated t value, so significant difference is there. It means we can conclude, investigator can conclude, there is a significant effect of drug X on Y on lymphocytes. If any patient or any individual want to improve lymphocytes, in that case, he should take drug X, since in this example, the calculated value is higher than the tabulated value. So we have discussed about the application of dependent t-test. The main difference is simple. In that case, we compared two independent groups. In this independent t-test, we compared two different observations of the same group. And in independent t-test, our research design was static group comparison design. On the other hand, independent t-test, in this, our design is a single group design. Now we will discuss manually by both the softwares, that is by MS Excel as well as by using SPSS. Please remember, during the calculation of independent test, we entered the scores of males and females, both the groups, in separate columns. But in SPSS, we entered all the scores in a single column. And in this same, we in Excel, first one is the pre-test scores, and the second one is the post-test scores. I am taking 10 in pre and 10 in post. And this is the second observation, post-test. After, suppose 1 week supplementation of drug X. Now go to data analysis. In this, instead of selecting t-test 2 samples assuming equivariances, we have to select t-test paired 2 samples for means. Click on OK. We have to enter the data in the same way. Click on the arrow in front of the variable 1 range, select all the scores including heading, that is pre. Again click on the same arrow, and then click on the arrow in front of the second range. Again click on the arrow, opt for labels, click on OK. The results are in front of us. See how to interpret the results. In case of the pre-test means, the pre-test mean is 43.7, post-test mean is 56.7, and the t value is 3.8, and the critical value is 2.26. We can take decision by using two different ways. We can compare with this critical value. If the calculated is higher than that, this tabulated value or critical value, significant difference is there, since in this example, in this hypothetical example, calculated t value, that is 3.80, is higher than the 2.26, that is the critical value. Significant difference is there, is yes, there is a significant effect of drug on dependent variable, that is lymphocytes, in this hypothetical example. Another way to take decision is, we can see this p value, significance value, if this value is less than 0.05. But in the medical sciences, the medical professionals conduct their studies at 0.05 level of 0.01 level of significance, since they conduct their studies in the controlled condition. So they have 99% confidence level. So if this value is less than 0.01, in that case you can say that yes, there is a significant effect of drug on this, or there is a significant difference between the pre and post. So we have calculated this t ratio by using this Microsoft Excel. Now I will repeat the same by another software, that is SPSS. Differences in data view. In independent t-test, we have to enter the scores of both the groups in the single column, but in this we have to enter the scores of pre and post, the scores of two observations in the form of a pre and post in the separate columns. Then there is no need to give label. In the first column we have the score of pre, in the second column we have the score of post. Now data entry is complete. Now how to calculate? Analyze, go to compare means, and see there is a paired sample t-test, and bring pre and bring post in the paired variables, make a pair, click on OK. The results is in front of us. Match the results with that Excel output. The results are same. For pre, the mean is 43.7. For post, 56.70. T value is 3.9, 3 point something, and it's not, it's a significant. This value is significant since the value is the significant value is 0.004. It's less than 0.01 also. So it is concluded that there is a significant effect of drug X on lymphocyte counts. So we have discussed about the application of this dependent t-test. If you have any type of question regarding this also, you can ask. Again, I repeat, there are two major differences between the independent t-test and dependent t-test. One is independent t-test is used to conduct survey studies, especially comparative survey, and dependent t-test is used to conduct experiments. Second difference is, it's clear, we have discussed independent t-test. In independent t-test we require two independent groups, but in dependent t-test we require two different observations of the same group with intervals in between. There is no fixed interval. That interval may be 1 day, 1 week, 1 month, maybe 1 year. That is decided by the investigator, what type of study he or she want to conduct. Now your questions are invited. After that, we will discuss about the third type of t-test, that is one sample t-test. Since one sample t-test is also used in biomedical researches. Sir, Paddy sir.
Good evening, sir.
Good evening, madam. Good evening.
Sir, I am Dr. Priyanka from Faridabad. Sir, I want to ask one question. How to calculate, sir, R, coefficient of correlation?
Madam, same as independent t-test and dependent t-test, there is a methodology to calculate R. There is a formula. We have to put all the values in the formula. If you, after the completion of one sample t-test, I will show you how to calculate.
Madam, that is another type of test, and we'll discuss that later, maybe next weekend. So this weekend we are dedicatedly for the t-test. If you have any question on t-test, you can ask. Otherwise, I think you are joining our workshop also, na?
Sir?
Yes, sir.
Sir?
Yes, sir.
So Dr. Chaudhary will be physically present in the 3 days, okay, in the last week of January 27, 28, and 29. So full 3 days he will be here to explain all those statistics in SPSS as well as will demonstrate in R.
Okay, sir. Okay. Thank you, sir.
Okay. So he is the key resource person for the workshop.
Okay, sir.
Sir,
Okay, sir.
sir, I
Yes,
am
sir.
Dr. Ankit. Yeah, sir, I am Dr. Ankit from AIIMS Raebareli. Sir, I have one question. What I understand P value, but I don't understand what is T value. Is it different? What is T value?
Yes,
T
sir.
value.
Sir, T value means the final output of t-test, maybe independent t-test, maybe dependent t-test, maybe one sample t-test. And this T value is also known as T ratio. Sir, is it clear? Now,
Yes, sir.
now in case of P value means the value of a significance. There is a difference between P and T. P means significance, T means T ratio. Is it okay, sir?
Yes, sir. Sir, another question is that if we want to run a t-test, the sample size of two groups must be equal, or if it is different, we can also run.
Sir, it's a good question. Sir, t-test can be, sir, in case of independent t-test, We can conduct the study by taking equal sample size as well as by taking unequal sample size also. But it's clear from independent t-test, since we are going to take two different observations of the same group, so there is no issue.
Okay, sir. Sir, if we want to highlight the degree of freedom, then what will be the degree of freedom if the sample size is unequal? Because it is n minus 1. So n will be the
No,
lowest
sir.
where.
Sir, degree of freedom is not n minus 1. In independent t-test, degree of freedom is n minus 2.
Okay, okay. Okay, sir. So, and if there are.
Sir, the degree of freedom is n minus 1 is in dependent t-test. But in dependent t-test, we have only one group.
Okay, okay, okay. So, sir, for independent t-test.
So there is no issue of unequal sample size since we have only single group.
Sir, I have just if we want to show the degree of freedom for paired for unpaired test, for example, independent sample, and one sample size is 20 and one sample size is 25. So degree of freedom will be at minus 2. So it will
45 minus 2.
Okay, so it will be the lowest one. मतलब two independent groups है तो उसमें एक group का अलग होगा degree of freedom और दूसरे का degree of freedom अलग होगा.
No, sir. You have said that in one group you are having 20, in another group you are having 25. So n minus 2 means total n. N means 20 plus 25, 45. 45
okay,
minus
sir.
2.
Okay, sir. Now I understood. Thank you, sir.
Hello, good evening, sir.
Madam,
Sir, my name is Dr. Shilpa Nelikal. I'm a senior resident in GMC Nagpur. Sir, I'd like to ask you, so you compared the tabulated value with the calculated value. So I also like to know, like in SPSS, there is no comparison. We are only looking at the p-value. Am I correct, sir?
Yes. There is no need. There is no need to calculate nowadays. Our purpose is to find out the significant difference between the two observations or two groups. And this is fulfilled in by both the ways, by comparing the calculated t with the tabulated t as well as by seeing the significance value. If
may I answer this question?
Sure, sir.
So, Dr. Silpa, in earlier days, maybe when the software is not accessible to everyone, when the Excel also do not have those features, maybe in early 2000, 2002, 2003. So we used to refer to the statistics book, and backside of statistics book, you will have the tabulated value, the T statistics, chi statistics. So those are there. But nowadays, the software is accessible to everyone. Okay, even if you don't have Excel or R or Stata, SPSS, so Excel can do your job. So therefore, nowadays we don't need to see those tabulated values because software is giving the reference T statistics as well as whether it is significant or not. So it is making our life easier.
Okay.
So
sir.
am I correct? Am I correct, sir?
Yes, sir. Nowadays, sir, there is no need of tabulated value.
Sir, one last thing, sir. Sir, I just like to know how will you write the conclusion if you are we normally suppose like you said, we are using the software. So in this, how do we write the results, or how do we what is the best way, which is the most appropriate way to mention the concise the results of this finding?
Madam, the result will be same by adopting both the ways, by comparing with the tabulated value or by seeing the significance value. If the significance value is less than 0.01 in biomedical researches, it is concluded that there is a significant difference between two observations, or we can say that between two independent groups.
Okay, sir. Yes. Thank you so much, sir.
Excuse me, sir. Sir, I am Dr. Ambrish from AIMS Bhubaneswar. Sir, the dependent t-test you explained, if the participants have been categorized as male and female, and the same question will be reframed as what is the effect of drug X on female participants as compared to male, then in such kind of question, which kind of statistical test will be used?
Sir, if you are going to conduct the study on two different genders, in that case, there will be different design. That will be a design means first you have to divide the groups into different sections. There is separate in males, separate in females. In that case, you may use two-way ANOVA also. In that case, if you are going to take control group, in that case you can use ANCOVA also. That will depend on the selection of the design. It's simple. If we are conducting the study by taking a single group design, we are having a single group and we are having two different observations in the form of a pre or post. And if we are giving a treatment in between, in that case only we have to apply dependent t-test. If we have two different groups, in that case that becomes a two-way. It is okay, sir?
Okay, thank you so much, sir.
That is a separate issue. We will cover. If Dr. Padi permits us, then we will discuss about that also.
Yes, sir. Today we have time, so you can take as much as you like because it is a weekend also for you. So if you are comfortable, then you can take as much as time you like. Because today I am the host, so I will close the meeting whenever this meeting ends.
Okay, sir. Sir, one technique remains. One technique remains. After that, we will discuss the different issues.
Yes, sir. Today let us focus completely on t-test. Next week we will discuss on R or other or chi-square test.
Sure, sir. Sure. We can discuss, sir. We can discuss.
Sir, I have a doubt, sir. Sir,
Yes,
for
madam.
comparison of means between two groups, is there a minimum criteria of minimum sample or something in one group? Even if it's two samples in both the groups, we are doing t-test?
Madam, there is no this type of evidence, but at least we should conduct our studies with minimum. It is advised by the eminent scholars, minimum 10 units should be there.
Okay, sir. So if we can't do t-test and we are doing a non-parametric alternative, are we comparing mean itself or median or something else?
Madam, if the please see, in the first technique we have discussed about the application of the independent t-test. In independent t-test, we compare two means. But you are saying if we want to compare median, we have to compare median in case of non-normality. The parallel technique of independent t-test, that is known as Mann-Whitney test, that compare the median of two groups. This is the difference.
Oh, okay, sir. Got it.
Good evening, sir.
Good evening, sir.
Yes, I'm Dr. Ashok from PGI Chandigarh. Sir, it's a very excellent session I've seen yet now. Sir, you have explained t-test on Excel and SPSS beautifully. So, sir, may you give demo on R also, R software?
Sir,
yes,
I'm
Dr.
Ashok, I'm not familiar about R. I didn't use R.
So during the workshop, a separate session, separate instructor is there, as well as me. The same thing, Dr. Rajiv will explain about SPSS using the concept in SPSS, and will demonstrate the same thing in R. So by attending the workshop, you will be benefited in both R as well as SPSS.
Thank you, sir. Thank you, sir.
Dr. Saab, I can explain by using Minitab. It's also a good software. By using Statistica, but I am not familiar about the R.
Okay, sir. Thank you, sir.
The main aim is learn the concept. All statistics software will generate the same value, whether it is R, SPSS, Stata, Statistica, or Excel. So software has no meaning until if you do not clear your concept. You should know when to apply T, when to apply chi-square, when to apply correlation coefficient, regression. Those concepts should be cleared. Then software will do the job. Little bit of tweaking, technical expertise is required to manage the software. Even Dr. Rajiv is explaining using the Excel, which is available to everyone in your system.
Yes, sir. Thank you, sir. Thank you.
Hello, sir.
I'm
Dr. Rekha from AIMS Kalyani. I have a question. Like you said, this pair t-test intervention is required. So as you have said that minimum sample size should be 10. So there is no limit to the maximum number. So in the previous test, you said that homogeneity of the data should be tested. So you showed on the SPSS software. Can you show? Can it be done in the Excel sheet?
No, the facility is not available, madam, there.
Okay, sir. Thank you. Then how will we test? We have to get that accessibility to SPSS then.
But madam, in Excel, there is a option of CC. Separately, you can calculate by using both the ways. Is it visible, madam?
Yes, sir.
Go to data, go to analysis, go to data, analysis tool pack. See, both the options, there is no provision of homogeneity or variance, but see, same test is available. T-test, two samples assuming equal variances, as well as T-test assuming unequal variances. By using, you can use both. Madam, is it clear?
Sir, we have to test on both the things.
No.
So suppose, sir, I have collected data of 100 candidates.
Suppose if you have a doubt कि homogeneity of variance is not there, in that case, assuming unequal variances, you can go for that also.
Okay, sir. Thank you, sir.
So, madam, if you have not access to SPSS, then you can use R. R is open access software, and we will demonstrate the. If you learn the basics of R, then all statistics can be performed there. So, therefore, we encourage everyone to migrate to R instead of SPSS and Stata, because R has a lot of higher from basic to advanced level of statistics, as well as it can make your life easier. So, if you have noticed in the beginning phase how I demonstrated the meta-analysis in less than 5 minutes. Okay, so it can do the analysis as well as it can generate also a report for your manuscript writing, your method section, even if it can write a paragraph of your results. Interpret the forest plot, funnel plot, bubble diagram, everything it can interpret as a human language. So everyone, I request everyone try to learn the basics of R. It will be make easier your life.
So, sir, can we have a session on installing the R and its packages?
Yes. Before the workshop, I think maybe in the next week, I will demonstrate how you can install R, the basic packages that should be loaded before you join the workshop.
I have a question.
Yes,
please.
As you said that in order to first apply the test, we have to check whether the assumptions are all met or not. So as you just mentioned that the homogeneity of variance is to be tested as well as the normality. So just in case if the variance is not found to be homogeneous, so we will take that one in which we are assuming that they are not homogeneous. But the normality assumption has to be verified. It has to be met, right? Just to use the parametric test. So
Yes.
in our scenario, for example, the variance, they are homogeneous, but not the normality. Can we use the parametric or should we go for the non-parametric?
We should go, madam, we should go for parallel non-parametric in that case. That is every parametric technique has a parallel non-parametric. The parallel non-parametric technique of dependent test is Wilcoxon matched paired sand rank test.
Okay, so our focus should be the normality. The variance can be like.
We cannot focus on normality. That will be, we don't know what type of data we are having.
Okay.
We should focus on the testing normality.
Yes. So like to decide whether to use the parametric or the non-parametric, we should first see if it's normal or not. Because for the variance, we can also
madam, this will be decided by the normality of data. If the data is normally distributed, go for parametric. Otherwise, go for non-parametric parallel technique.
Okay, thank you.
Sir, I have a question.
Sir.
I just wanted, like, we are using Ttest. So, in which case we are using chi-square? Can you just compare with an example? So that.
Sir, chi-square can be used in categorical variables. We have discussed about the different scales of measurements. We have discussed about 4 scales of measurement: nominal scale, ordinal scale, interval scale, and ratio scale.
Yes, sir.
Out of these 4 scales of measurements, only we can apply chi-square in case of the nominal scale. when we collect data in the frequency or counts. Suppose if we want to compare different categories, means comparison of the number of patients in different states, that will be discrete series. Suppose Haryana has 3 lakh patients, UP has 4 lakhs. If we want to compare this whole value, discrete series or a categorical variable, and this categorical variable may be dichotomous, having 2 ends, maybe smoking, maybe polytomies. Polytomies means having more than one category. Is it okay, sir? And there are 2 different uses of chi-square. One is known as equal occurrence hypothesis. We can compare categorical variables. And second one is independence of attributes. We may have 2 attributes also.
Okay. Dr. Dibjot will have a separate session on chi-square. So let me give you a brief introduction about where you can go for chi-square and where you go for t-test. So if you have looked at any article of a journal, the first table 1, okay, you will find many, so for example, which describes the basic characteristics of the study participants. Okay, for example, you are comparing the diabetic status between 2 Chandigarh's different sectors of Chandigarh. Okay, so where you are collecting data for the age, gender, socioeconomic status, their occupation, family history, those type of data you are collecting. So apart from only age is collected in the continuous scale, for example, say 20, 30, 40, 50, 60, like that age. Rest of the age, everything will be categorical. Say socioeconomic, occupational, educational, gender, all are categorical variable. So if you want to compare between the different sectors, what is this data? So those will be done by the chi-square. Okay, socioeconomic, occupation, education, gender, all will be chi-square. Only age is continuous, so age can be done using the t-test. So this is the simple example.
Yes.
And we'll demonstrate application of chi-square in subsequent sessions. And yeah, I think you are a participant of our workshop, so all will be demonstrated there.
Thank you.
So am I correctly said, sir? Professor
Yes, sir. You are right. Yes, sir. Yes, sir.
Just finish the last t-test. That is the most important one.
Okay, sir. The third type of t-test is known as one sample t-test. We have only one sample. See the definition. One sample t-test is a statistical technique used to find out the significant difference between a group and a specified constant. We can say that we can compare a group with a fixed value. We can compare a group with a normative value. We can compare a group with a target. And in the field of biomedical sciences, we have different norms. We have norms for fat percentage. We have a norm for systolic or diastolic blood pressure. We have norms for hemoglobin contents. We have norms for myoglobin contents. We have norms for blood glucose level also. Okay, this much is required. We have a target. So formula is very simple. It's a t value, t ratio is equal to dm, difference between means, upon under root standard deviation square. Since we have one group, so we have one standard deviation upon n means we have a single group. This is the formula. Example is the investigator want to conduct a study comparison of hemoglobin of PGI-MER female students with the normative value. And the study was conducted on 30 subjects and hemoglobin was measured for all, and the normative value of hemoglobin for this is 12. In this hypothetical example, for females, we fix the norms. This value is required, that is 12. So we have to compare a whole group consisting of 30 females of PGI-MER with the value. I don't know how to remove this. What is, sir?
Which one?
This appeared. Please wait. How to remove this?
Oh, so it appears as a pen. So maybe there is a pointer option.
Yes.
Yeah.
Now it's okay. Objective. The objective study is to find out the significant difference between the hemoglobin of PGMIR female students with the normative value. In this hypothetical example, the normative value is 12. So hypothesis is the investigator formulated null hypothesis. There is no significant difference between the hemoglobin of a group, that is PGIMER students with the normative value of 12, and the technique which is used to find out the difference between a group and this is specified constant, that is 12. One sample t-test used. See, there are see in this example there are two groups, and we can thus this at 0.05 level of significance, the tabulated value is 2.45. How to draw conclusions? The way of drawing the conclusion will be same. Calculated value is 4.70, tabulated value is 2.045. We have to follow the same. Means the calculated value is higher than the tabulated value. Yes, it is concluded that there is a significant difference between the group and a specified constant. There is a difference between the hemoglobin contents of a group with this 12. Since this calculated value of 4.70 is higher than the 2.045, now I will show you by using this. How to remove? I don't know how. Someone wrote on this. Yes. Okay. Now see. Ladies and gentlemen, this facility of one sample t-test is not available in Excel. So we will calculate by using this SPSS. See, I am going to enter the scores. In SPSS, we have only one group. Suppose we have 20 females. I am entering the scores of this hemoglobin of the females in percentage. This value is, and our target is, our normative value is 12. Total number of subject is 20. See, we have to compare these scores with their target. This is the hemoglobin level. See the commands, how to do this analysis. How to remove this? I have to click on analysis. So Dr. Padi, we have to remove this. How to remove this? Earlier it was okay. Yes, got it. See, click on analyze, click on compare means, click on one sample t-test, bring this hemoglobin level in the test variable, and our test value is target, or we can say that normative value, or we can say that specified constant. And in our hypothetical example, the specified constant is 12. Enter this, click on OK, see the results. We calculated this hemoglobin of 20 subjects. The mean value is 8.95 and the t value is 11.05. It's a significant. It means there is a significant difference between the hemoglobin level of a group with a target or a normative value. It means improvement is required. We will suggest the group improve your hemoglobin level, since there is a difference between your hemoglobin, required hemoglobin level. Now your questions are invited.
Sir, I have a question.
Yes, madam.
Okay, so here we were comparing the data with a normative value. So, for example, we are not saying that it is equal to, let's say, whatever it is. We are saying that it is either less than or greater than. So, in less than or greater than scenario, how are we going to calculate in SPSS?
Yes, it's less than, madam, we have to, this t value will tell us if there is significant difference or there is insignificant difference. But then we have to go for this mean value. Since in this example, in this hypothetical example, mean value is less than the target, mean value is less than the normative value. In this example, the normative value is 12 and the mean value is less than that. It means the group possesses the low level of hemoglobin in comparison of target. So by seeing the mean values, by comparing the mean values, we will conclude.
No, my question was like, for example, you wrote in test value 12. So if the question says whether the hemoglobin level of the females is less than 12 or let's say greater than 12, so the less or the greater than sign, do we put this anywhere in the SPSS when we are putting test value equals to 12?
In this, there is no need. There is no need. This facility is not available in this, but there is no need. Only our purpose is this technique, this one sample t-test fulfills that is there any significant difference between the target and a group values. This fulfills this.
Okay, thank you. One more question I had, like
So, sir, in this case, we are taking 12 as the reference.
Yes, we can say reference, sir. We can say the target. We can say
Okay.
specified constant.
Yes.
Different terminologies may be used.
Yeah. Okay.
I had another question. I wanted to know the parallel non-parametric test for this type of test.
The parallel non-parametric technique of this in one sample t-test is known as sign test.
Okay, thank you.
So today we have discussed about 6 different techniques. Independent t-test, parallel non-parametric technique is a one magnitude new test. We have discussed about dependent t-test. Parallel non-parametric technique is Wilcoxon matched paired sign rank test. In the third type of t-test, we have discussed about one sample t-test, and parallel non-parametric technique of one sample t-test is known as sign test.
Sir, I have one question. I'm Dr. Rupesh Sahu. So in most of the biomedical researches, we take significance level as 95%. Now,
In
if
marks
we
of
take,
no, in biomedical researches, we take 0.01. You will see in all the in all PubMed index journals, Web of Science index journals, and in Scopus index journals. In biomedical researches, we take the significance value 0.01.
okay. So the confidence level which we specify before the study, usually we take it as 95%. Is it
95 or 99, it doesn't matter, but 95 is a broader range. If you are high accurate and you want a very narrow result, then you can take 99, 1%
So
error.
is
But
there,
if you are taking 95, then there is no harm.
so would there be any differences in the calculated p-value against
Sample
the?
size, there will be difference. If you are taking 95% confidence interval and 99% confidence interval, your sample size will be much higher in the 99 than 95. And then
Interpretation of the
p-value, there will
yeah.
be not much of difference. Even if when you are talking about your 99, your p-value can be significant and 0.0, but you are saying that you will consider only p-value as 0.01. Okay. If
Yeah,
it is
I find it
0.02, then you would say that you are rejecting. This, for example, you are talking about the effectiveness of a drug, means highly sensitive. Okay, where the chances of error is very less. So then in that case, you can take a 99% confidence interval and you are taking p-value is 0.01, not 0.05.
Yeah, that's what
If
I
you
meant.
wider your p-value, then there is a much larger scope. But if you narrow it, then you need your sample size. You need a much higher sample size.
And
Yeah, but
particularly
the
there is
interpretation.
one more point should be clear for all. There is a difference between confidence interval and confidence level. Here we are talking about the confidence level, not about confidence interval. Confidence interval is the interval that tells us about the confidence of our results. By the help of confidence interval, we can test the quality of our results. They both are separate issues: confidence level and confidence interval.
Yes, sir. I was talking about confidence level. We take it as 95%, but if you take it at 99%, then you have to take the p-value as adjusted 0.01. Then
Yes. It's
thanks.
clear that if the value is significant at 0.01, automatically that will be significant at 0.05. But it's not may or may not be the value which is significant at 0.05 level may or may not be significant at 0.01.
Thank you.
For testing confidence interval, we'll use a different test.
Sir, first we should have an idea what do you mean by confidence interval. Suppose, sir, the weather forecasting department conducted a study and predicted that tomorrow's temperature will be in between 0 to 50 degree centigrade. Is there any effect? Is there any utility of that? That tomorrow's temperature will be in between 0 to 50.
No.
There is no practical utility. Suppose the forecasting department predicted that tomorrow's temperature will be in between 0 to 5 degree. Yes, there is a practical utility. Same is applicable. It means the low confidence interval shows the good quality of results. There is a separate way of calculating confidence intervals, especially in experimental studies. You will find in PubMed index journals, in Web of Science index journals, in Scopus index journals, you will see confidence intervals in almost all papers, since that confidence interval decides the quality of the results.
So they will be calculated by a different statistical method, or
Yes, there is a separate that is a separate way of calculating that. If we are applying ANOVA, analysis of variance, we will calculate in different way. If we are applying ANCOVA, so we will calculate in different way.
And sir, one more question. In this one sample Ttest, if we use a range for the reference value like 12 to 16, can it be done or it would be a different?
No, sir. There is no. Yes, this is the weakness of the technique. We require a fixed value. We cannot enter the range.
Okay, sir. So that would be a different test.
Yes, you are right. In biomedical sciences, every variable has a range. Hemoglobin should be in between this to this. Blood pressure should be in between this. But we have to fix this, or we can take the mean value of a range. We can take that also.
If there is a range, we can use a different test, or we have to take the mean.
No, sir. There is no technique. We cannot compare the values with the range. We cannot compare with the range. For comparison purposes, we require a static value. That should not be flexible. Range means the flexibility is there.
Okay.
In this case, you can take the lower value.
Yes.
Okay, sir. Thank you.
So, okay, friends, do you have any more questions? Or if you do not have any question, then we may end the session. Or I can invite the last questions if anybody has any doubt. So those who are interested to learn more in the 1 hour, it is not possible to demonstrate the concept using R and SPSS or Excel and cover much more concepts. So it is the time is limited. Therefore, we are conducting this a 3 days full workshop in PGI. So those who are interested, I have shared the link in the chat. So you can join there. Professor Rajiv Chaudhary will be physically present in PGI those 3 days. So he is very fascinated to teach the students.
Sir?
Yes, please.
One last question, sir. Sorry to bother you.
Yes, please.
Sure.
Sir, for those the non-parametric tests like Manutnier, Wilcoxon, Lagrange, or sign test in SPSS, so I have to go for the analyze, then the non-parametric test, in that toolbar. Then you have to select the particular test like man-Whitney or Wilcoxon. That
Yes.
way or some other way is there, sir, to calculate.
That is not specified by the name. That is given by the name. Two
One independent sample, one sample, one,
yes.
two samples, one independent sample like that, sir.
Two samples means independent man-Whitney test. One sample means one sample t-test.
Yes,
K samples is a parallel technique of one-way ANOVA. I can demonstrate. Sir. Okay. See. Sir, it's visible on the full screen.
Yes, sir. Yes, sir. WebEx page is opening, sir.
Suppose if we are there are suppose we have 20 students, 20 subjects. In this, we divide into two categories, 10 males and 10 females. Give any variable. This is a variable. We don't know which variable is there. Variable, maybe. And this is the gender. And we give the label. One means male, add. Two means female, add. Click on OK. Go to analyze. See, sir, is it visible?
Yes, sir, visible, sir.
Sir, go to now. Where is my cursor?
Yes, sir. Non-parametric.
Now, see, two independent samples. The parallel technique is man-Whitney test. It's not written here, man-Whitney test. We will click on two independent samples. And here we have the option, see, man-Whitney U. Is it okay?
Yes, sir. Yes, sir.
Bring this in this, grouping, everything will be same, 1 and 2. One madam asked a question. This man-Whitney U test compares median, and in independent t-test we compared means of two groups. Here this compare median. See, this is the man-Whitney U value. The interpretation of the results will be same as independent t-test. If this man-Whitney U value is significant, it means significant difference is there between the two, that is males and females. Otherwise, sir, is it clear?
Kindly
Yes, sir.
ones if possible.
So Rahna here, sir, from Kerala. So I had asked that doubt. So when you write the result of man-Whitney, do we need to write the means of group or medians of each groups in the result?
No, madam, we did, it's not required. Our result will be on the basis of a single value, that is a t value. Since this t value is significant, difference occurs, or different insignificant difference occurs, we have to write. There is no need to write. It is advised by the experts that too much use of statistics should be avoided. We paste the same table, we paste the whole output of the this SPSS or Excel or R, or there is no need. We should include the values which are essential for the interpretation of the results, not more than that.
So we when we write the comparison result of the man-Whitney, so we write the group names in the first column. Second column we write the number of samples, and
Yes,
third column
yes. If you include that format, in that format we have to write down the median. If we use this format.
Okay, sir.
The trend is going on. We write mean of the groups, then t-value if you are using this column. But nowadays you will find there is no one male, female, and only t-value. It is also given. That is also correct. But if you want to include the point estimate, it means any measure of central tendency. In that case, you are right. Instead of mean, we have to include median essentially.
Okay. So instead of standard deviation, should we add something?
No. In this standard deviation is not required. Only median is sufficient.
Okay. So
Wait.
sometimes people ask for
No,
inter
madam,
quartile.
please wait. In that case, there are three measures of central tendency: mean, median, mode. Independent t-test compared mean. This Mann-Whitney test compared median. And the if we are using mean, in that case we use standard deviation. But in that case, you can if you want to include the scatteredness of the score, if you want to include dispersion, in that case either include quartile deviation or mean deviation.
Okay. Okay, sir. In the Mann-Whitney.
Yes, in Mann-Whitney.
Yes.
Instead of standard deviation, use include mean deviation.
Okay. Okay.
Or quartile deviation.
Okay, sir. Thank you, sir.
Or you may include range also, minimum and maximum value. You may include minimum and maximum.
Okay.
I have a question.
Yes, madam.
Sir, I'm confused about the two-tailed and one-tailed, because like the last test that you did, the Mann-Whitney test, in the last line it said two-tailed test. So like why two-tailed? Sometimes I see one-tailed. So like, is there a difference, or we should just completely ignore it?
Madam, one tail and two tail, that is based on the directional or non-directional hypothesis. In this, we formulate that there is no significant difference between the, suppose, for example, there is no significant difference between the hemoglobin of males and females. But if our hypothesis, it is hypothesized that male will possess higher level, it means in this, the tail is elongated towards the right or left. It means direction is specified in hypothesis. That is the concept of two-tail test. Males will be better than females. It means significant difference will be there, but males will be better or females will be better. It means that we specify the direction. Madam.
Sir, I have one question. If we are reporting Mann-Whitney test in our research, then we need to emphasize on U value, or we just say that P value less than 0.05 our tests are significant.
Sir,
how we can report the Mann-Whitney?
Sir, language may be different, but we have to justify, since this calculated Mann-Whitney value is significant at 0.05 or 0.01 level of significance. So it is concluded that we require only two values, the value of significance as well as the Mann-Whitney value. We require two values.
So, thank you, sir.
Sir, when will we cover ANOVA and ANCOVA?
Madam, that is a long story. And ANOVA, there are 5 different types of ANOVAs and variances. One-way ANOVA, repeated measure ANOVA, between two-way factorial ANOVA, within two-way factorial ANOVA, within two-way factorial ANOVA, and ANCOVA. ANCOVA is the best suitable technique to conduct experiments.
Dr. Priyanka, you are a participant of this workshop, so you should not be worried. Okay, so next week I will demonstrate how to install your R and basics of R. And during workshop, everything will be covered till logistic regression and linear regression, starting from basic sample size calculation, t-test, chi-square test, correlation coefficient, ANOVA, ANCOVA, linear regression, logistic regression, all will be covered in these 3 days of workshop. So you should not be worried about that.
Okay, thank you so much, sir. Thank you.
So better you should be prepared with any one of the software, either SPSS or R, during the workshop, so that you will have a hands-on practice along with the concept.
Okay, sir.
So next week I will demonstrate how you can install R and basic of what are those basic commands.
Yes, sir.
Thank you, sir.
So friends, if you don't have any further question related to this T-test, then I thank you everyone. Being a weekend till now, it is almost 1 hour 45 minutes, and there are more than 100 participants present in this room. So I appreciate your encouragement and interest for learning. And we thank Professor Chaudhary for constantly speaking more than 1 hour and 30 minutes. So we thank Professor Chaudhary for your kind participation for this webinar series, and we hope we'll continue this relationship in future. So hope possible if next week after my installation of R software, if time permits, so then we'll discuss, since you are coming physically to PGI Chandigarh, and hopefully all the participants will be benefited your physical presence. And that's, thank you everyone, and thank you Professor Chaudhary.
Thank you, sir. Thank you. Thanks to all. Thank you.
And we thank the Department of Telemedicine for providing this facility. Otherwise, it is impossible to host 200 participants in this room. Thank you.
Thank you, sir.
Thank you, sir. Thank you,
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir.